Okay, so our next lecture is under full wave rectification. So still ang gagamitin natin is ideal model for the diode. Okay? And of course, ang input natin dito is still a sinusoidal input. Okay? Having a peak value of positive peak Vm and negative peak Vm. Okay? So, ito yung ating input. And this is your bridge type network. Okay? So, we are asked to draw what would be our output waveform. So, at this point, again, still, ang idodrawing natin is the output. So, supposing our input wave, yan, input is a sinusoidal. Positive peak and a negative peak. So, positive Vm, negative Vm. What would be the output waveform? Okay, so ano ang output waveform? Still positive Vm, negative Vm. That is the zero part. Okay, analogy. We must determine kung kailan naka-forward bias or naka-reverse bias ang ating mga diodes. Consider natin, during positive cycle, okay, redraw ko lang, so diode 1, we have diode 2, diode 4, and this is andito yung ating R plus minus V out. Yan yung redrawn circuit. Okay, consider natin positive cycle. So, this is D1, D2, D3, and D4. So, during positive cycle, that is positive, negative Vm. Okay? So, we have to check kung anong type of biasing yung ating mga diode. D1, kung i-consider natin, ang D1 natin, cathode is connected to a more positive Vm. Okay, so, anong condition ng diode 1 natin? Okay, so it is reverse bias. D2, connected yung anode to a more positive, so D2 is naka-forward bias. D3, anong connections natin? D3, anode is connected to a more negative, so therefore, reverse bias. And D4, ang cathode natin is connected to a more negative, so that means forward bias. So, gamitin natin yung ideal, that means D1 reverse bias, so this is an open switch. Forward ang D2, close switch. D3, open switch kasi naka-reverse bias. D4 is forward bias, so that means this is close switch. So, paano ang direksyon ng current natin. Paano ang path na gagamitin niya? Since open to, open yan, okay? So, anong dadaanan niya? Mula dito, it will pass through D2, then goes to the resistance R, then goes back to D3, then back to the negative. That is the direction of the current. So that means, mula dyan, going here, pass through the V out, goes here, then back to the negative supply. That is the direction of your current. Therefore, meron kang complete path of current. So therefore, applying Kirchhoff voltage law, okay, this point, pag ganyan, so that is Vm. Anong sign ng ating Vm? Positive. Then, minus Vd2. Then, minus V out. Then, minus Vd4. Then, back to the negative side. Complete the loop. And that is equivalent to 0. Since ideal diode ang consideration natin, ibig sabihin, diode in the forward bias condition, ang equivalent niya is closed switch. The voltage pag closed switch is equivalent to 0. Therefore, Vd2 and Vd4, 0 yan. So, ano ang Vout natin? Equivalent to Vm. So, during the positive cycle, ito yon. Ang Vout natin is equivalent to Vm. So, peak value Vm. Okay? That is positive cycle. Ganun din lang ang gagawin natin during the negative cycle. Okay? So, during negative cycle, if we are going to redraw, so D1, we have D4, D2, D3, then we load. So, negative, positive Vm value. So, D1, D4, this is D2, D3, plus and minus Vout. So, same ang polarity ng ating Vout. Okay? What would happen? Mababaliktad yung biasing ng ating mga diode. D1 becomes forward bias. D2 becomes reverse bias. D3 becomes forward bias. And D4 becomes reverse bias. Okay? Apply natin yung ideal model. So, this would become open switch. Dito, close switch. Ito, magiging open switch. Dito, magiging close switch. So, kung ito, tapos ito ang open, paano ang loop ng current? Mula sa positive, goes to D3, goes to the resistor, goes to D1, and back to the negative supply. Okay? So, ibig sabihin, mula dito, papunta doon, back to the resistor, then goes then back to the negative supply. So that is the direction. So applying Kirchhoff voltage law again. Pag ganun, so that is, so mula dyan, positive VM. Okay, then minus VD3 minus the V out, ayan, then goes here, minus the voltage drop across VD1 equals to 0. Kasi bumalik na siya sa supply na peak value natin. VD3 and VD1 is equivalent to 0. So therefore, V out is equivalent to Vm. So during negative cycle, ang V out natin is equivalent to Vm. So therefore, during the negative cycle, at this point, equal to Vm value. So, positive Vm value. So, if we are going to continue positive cycle, ganun din, V out is equivalent to Vm. Then, negative cycle, another positive Vm. So, this would be full wave rectification. Okay, so this is another type of full wave rectification circuit. So, this time, using a center tap transformer. Okay, so as your activity, take a video of this explaining kung paano natin makukuha ang full wave rectification of this type of circuit.